Welcome to a new video in my Node.RED tutorial series, and in this video I want to talk about error handling in Node.RED. Based on my example, I think this topic gets a little bit neglected because in most cases, even if you make some programming errors within Node.RED, the impact is really low because even if one of your function model fails, that usually impacts a single message. And let's say if the message was incorrect in formatting or content anyway, you just don't really care. But then, if you don't pay attention to these errors, then you might have other exceptions in your program, and you just, wouldn't realize that you have some issues, especially if you are, processing data 24/7, and obviously you're not going to monitor that 24/7. So when you are in the editor and you are looking at the debug, there is no errors, so you just leave it run, and then, errors happen in the background. So I think it's a good idea to pay attention to that, and then maybe collect these issues. So what I'm going to talk about in this episode is, well, first of all, just recap how these errors occurs and how we usually see them in the Node.RED in the editor, and then also talk about the the special node that Node.RED has created in order to handle exceptions, catch errors, and do something with them. And I come up with a couple of examples how you could do that. So obviously in my example, what I wanted to do is I wanted some sort of monitoring or logging of these errors. So if I come back after a day or a couple of days, I can see that if my application is, or if my flow is making any errors. And if it's making errors, I can have an idea how many times it occurs. So it would just aggregate these issues. So I know if it's a one-time issue or maybe it's happening, 1,000 times over the, let's say, last 24 hours. But then if you have just a few amount of errors or a few, different type of errors, what probably I also want to do is just collect all of these errors individually. So I can just analyze them one by one. And then just to add you just one more example, I think is a good idea that you can do emailing these errors. Obviously, save them in a file for later revision and checking your log files. But then maybe you can just have an email report at the end of the day, how many issues occurred within your flow in the, let's say, the last 24 hours. Just to quickly summarize the example that I'm going to show you. So I've created a couple of different nodes, and well, obviously they are all function nodes, and they have some various errors. So I try to force some errors in these function nodes. I mean, nowadays with the version 3 of Node.RED, there is so much validation and checking happening in the function node that actually it does going to remind you or note common issues, but still, obviously, JavaScript, you can make mistakes, especially if you are assuming data types and data structures. So I have these set of nodes that I can use to generate errors. And what I'm going to do with these is that, well, first of all, I'm going to collect them, obviously, with the catch node, and I want to do collection in two different ways. So I want to aggregate these errors so I can tell how many occurred for a particular type. And then if I don't have, let's say, so many errors, then I might just want to collect them individually. And I created a simple UI where you can see the errors, but I think mostly you just want to store it and maybe email it to you. So I created another example flow which collects all these issues and then puts them into a nice email, and also adds an attachment to it. And just to show you how it works, so if I let's say create this error here, then now we can see that we had an error, which is this is the error type. It is coming from the error1 source, which is the the name of the node which raised the error, and it's a function node, and it has occurred once, and then the same thing also gets logged here. And if I trigger it again, or if I trigger it multiple times, then we can see all the individual errors, which are all the same, but they are happening at different times, and maybe the error message could be slightly different. But what it also does here is that because the error message is the same and it's coming from the same source, it just counts them. So you can really tell that was it like a one-time issue or it happened like 100 times. And of course, if you create the errors from other nodes, then those get logged as well. So now we can see that this happened 2 times, this also happened 2 times, but then you can see the details here as well. It's very simple. And of course, at the end, we will see how we can email this collection to ourselves. And if I just do this, so now it collects all the information, it sends it over an email. And I can see that in my Gmail account. So you can see there is an error summary. So I included the summary or the aggregate results in an email, and then you can see the individual details in an attached CSV file. So again, you can store it, or you can just analyze it. And I think this is a good way of looking at these issues, because then you can look at the summary, and let's say if you have, you know, 1 or 2 errors, then you already know that, okay, yeah, I have some issues that I need to fix, but let's say it's not happening, you know, hundreds of times or dozens of times. Maybe you can just ignore it. So that's the whole flow. But before we start, let me just give you just a rundown again of how normally the exception happens. So if I copy this example flow and I deploy it, so this is not being, the error or the exception from this is not being handled by Node.RED at the moment. So this is how we usually, you know, find errors and deal with them. So you go to the debugger, and then you can see that there was an error in the function node. That's the error message, and it's coming from the error1 function node. Well, the error1 as in that's the name of the function node. And also another way of looking at these issues is that if you are logged into your server where the Node.RED is running, then, so I have a PuTTY here, so I'm in the terminal. You can issue this command which says node-red-log, and it's going to show you the log. So that shows me the last couple of errors, and this is like a live log. So if you keep it like this, then it will automatically update anytime a new error has occurred. So I just trigger this error again, so you can see again timestamp that it is an error or a warning or an info, but I created an error here. It was coming from a function node which is called error1, and that's the name of the message. So exactly the same for information you can see here. So you have these 2 ways at least that you can use to, you know, look at issues that are happening in your Node.RED system. Okay, so that's how normally we see these errors. And I think it's okay that this happens. Obviously, we create programs, we make mistakes, we don't handle all the different cases, and hence error happens. Especially in this case, for example, here in this code, I assume that the foo is an object because, sorry, a foo is an array because I want to get its length, but it's actually null, so it doesn't have a length. So these type of things that you wouldn't be able to notice just by looking at the code, because it depends on what data type your variable is at the moment. But again, that was just an example. You can have, you know, very different type of codes as well. So, and what I said in the beginning is that, well, at least I did not pay too much attention to these errors, because the impact is usually very sort of minimal, because unlike like, for example, a Windows application or just sort of like regular application, if there is an unhandled exception, probably that application quits and it stops working. But now what happens in Node.RED is we have these function nodes and other nodes which are, you know, some individual nodes, and they are processing a single message. So the processing of the message fails, but then that's not going to impact any other messages that are coming in. So again, in my example, if I have a function node which is expecting a certain data type, but a different data type comes in, the code is going to create an exception, and then the processing of that single message is going to fail. But if another message comes in with a data type that my code sort of assumes, then it's going to continue. So you know, there is no I would say like real impact, or as I said, the impact is very minimal. So this is why I also tend to, you know, not do too much exception handling, which normally you should really do if you are using any, you know, traditional, I wouldn't say programming languages, but traditional applications. There is a standard node here in the common palette, which is called a catch, and this is designed to handle errors. And when you put it on your flow and you go into properties, then there is nothing really here. So you have really 2 options. So you can say that I want this exception or this catch node to handle exceptions of all my nodes on the flow where it is placed on, or I can tell it to only look at selected nodes. So what I have done is, you can see that I have specifically selected that it's going to monitor, or sorry, handle exceptions on these these 4 function nodes. And this is why this one, the copy, is putting all the exceptions here, because that one is not handled by this catch node. So you can do either way, and of course you can have as many catch nodes in your flow as you want, and maybe if you want to handle exceptions separately for a set of function nodes from a different set of function nodes, of course you would create then 2 catch nodes. One is looking at, you know, first set, and the other one is looking at the second set. In both cases, so both sets would be handled, the exception would be handled, but then the message of that exception is going to come up from a different catch node. And if you go into the documentation of the catch node, then it's also explains how the, you know, what information the node is going to give you when exception occurs. So if I now trigger the exception from this error1 node, which is being handled or being monitored, let's say, by this catch node, what you would notice that we don't get the errors on the log. So the processing just continues. I mean, of course, the processing of the message fails here, so this message never reaches the debug node, but it is being handled by the catch node. So you can see that from the catch node I have this debug node which says exception data, and by the way, this is configured to look at the complete message object. And you can see that within, well, it still has the payload of the original message that has gone into the function node, which was a timestamp from this inject. So you can see the timestamp here. It didn't have a topic because yeah, there is no topic here. So it still retains the original message that has gone into the node which failed. But then it also has this error property, which contains the error, which otherwise we would see in the debug in this right side of the screen. And it also has another source object which contains the ID of this node. That is a function type. The name is error1, and it also has a count. I don't know how this count would be different from 1, but I didn't look at this variable at the moment. So this is the information that you get out of the catch node. So it's pretty much what you would see on the sort of on the debugger on the side. But now it's a message and you can do something with it. For example, you can log it. And this is what I have done here. So all these error messages, all these exceptions are coming out of this catch node, which contains the error message, it contains the name of the flow and the type of the flow, which raised the exception, and I can just, you know, start processing this information and logging it. Before I turn to the error handling, I just wanted to show you something else. So, I mean, obviously you can create errors by incorrect code, but there is also this function which is node.error, and here you can create an error message and you can pass the message object as well, and that also creates an error. So normally if you do this, then you will see the error appearing here on the right if it's not handled. So again, if I create a copy of these and I deploy, and if I do this, now you can see that this is my error. So this is, it creates like an error, but it doesn't stop the processing, because you can see that actually I get the result in debug 73 as well. So this just basically it acts like an exception, so it does all the logging and triggers all the catching or exception handling. But it would just let the processing to continue, because as you can see, the return message got executed. And also there is another one, which is the node.warn, where you can again just pass a message, but this is not being handled by the catch node. So you can see it always shows up as yellow, and again it just lets the processing to continue. And to be honest, I have used this for sort of debugging purposes. So if you have like a function node where it does some funny thing and you can't really figure out why, maybe it's some of the values are incorrect within the function node, you can use this node.warn just to, you know, type out some immediate results or variable values into the debugger, so you can actually sort of like debug inside the function node. But if you do the warning, if you do the node.error, then it will trigger the catch. So you can use it as, I mean, it's not really nice to say, but you can use it as sort of some sort of logging to create these logs within this flow that I'm presenting here. As I said, I wanted to log it in two different ways. The first was to create this aggregated collection, which is handled by this node or this function node. And what I have done here is I have created a key from the source name, so it's the name of the node and the error message. And like if it's a new error, then obviously I store it in, as you can see, I store it in a flow variable, and I have a counter. So I create it as a count1. You can see it here. So count1. So the exception occurred once. And then if the same exception comes in, then again I create this key, which is just a piece of text which contains the name of the node and the message of the exception. And I look in my list if this exists at all. And if it already exists, then I just increase the counter. So this is how I count how many times it occurred. And if it doesn't exist, then it just creates as a new entry. And by the way, you can see this from the summary output. So it's here. So at the moment, this is an array, and you can see that the first one is the type error, cannot read property length of null, coming from the error 1, and it has now occurred 6 times, and the last time it occurred was this timestamp. And then there is the same message coming from the error 2, so this this node, and it has occurred 2 times. And of course you can do the second one, the third one as well, is this error message. Well, that's the summary. And of course, then I have a template node, which basically just formats this information, this array, into an HTML table. And this HTML table is then fed into a UI template. And this UI template just displays it as a HTML table. I could have done some formatting, maybe it's a little bit difficult to read, so maybe you can add border 1 to the table so it appears the same way as this one, but I mean, you get the idea. You can style it either way you want. I just wanted to create a very simple template node here. I would assume that if you would use something like this, it's probably your own monitoring, so yeah, it doesn't have to be nice, but as I said, you can style it. So that was the aggregate collection. Again, I think it's useful if you want to really see if you have loads of loads of errors, or if you just have a few and you just have an overall overview of the, the number of errors and how many times they occur. But in other cases, you might just want to, collect all of these errors individually. So the output of this catch node also goes into this individual error correction function node, which it does almost the same thing. So it also collects all these in a big array, but it's not going to look for duplicates. So basically it just logs the error, and there is a collection size, which I only set it to 10. But you can increase it to, let's say, 100 or 500, and it's going to keep the last 100 errors or 500 errors. And it works the same way. So the exception goes in, and then it stores it in the all output, and then you can see this all output just increases. I mean, well, at the moment it doesn't go above 10, but you get all the timestamp and the errors and the source and the type here. Obviously you don't get the count because we are just logging them individually, every single one of them. And the output, so the output from this function node is going to collect all the all the errors, which goes into a very similar template what we have seen before, and that goes into another UI template, which is done here. So you can see now that this is why I have this. This is my errors, and if I trigger the error 1 again, then things move up, because now this is the latest error and we already reached 10, so obviously the top one, which was the earliest one, got deleted. And here just the counter just increased. So very simple, but again it works a great way, and it's a very simple flow just to collect errors. And as I said, all you need to do is copy and paste this part of the flow, go into the catch, and then click on select nodes and select the function nodes that you want to catch exception on. So this catch is really designed to, catch errors that you make within your function nodes when you build your, JavaScript code, but you can select any of the nodes for this catch node to handle exceptions, although I don't think that the standard nodes would create so many exceptions. I mean, maybe if you are using some third-party nodes which they don't have all the scenarios handled, then you can catch the exceptions from those as well. But once you have created that, it's then that's it. This code doesn't have anything that you can sort of like configure. There is no system specific settings. Probably the only thing that you can change is the collection size, so you can increase it to, as I said, 100 or 500 or whatever number you want. And if you want to monitor this outside the UI, then everything gets logged in the flow variable. So there is a summary all, which is created by this, and there is a errors all and the error summary. So that's the aggregate results. And then finally, the last functionality that I wanted to add is, of course, it's a good idea to have all these logs being collected. And if you are in the system, let's say regularly, then you can just look at these errors. But then you might also want to email it out, especially if you are developing a flow which you don't have easy access of. So it might be just easier just to check your emails at the end of the day. So I created this flow, which really what it does, it saves both of the aggregate error collection and the individual error collection into a file, and then the aggregate information inputs it into the email, and the individual gets attached to the email as an attachment. So at the moment, this is triggered by a simple inject node, and then first I used a function node, an earlier code that I created, in order to generate not a random file name, but let's say if you are executing in a daily, then it generates a daily file name. So you can see here that I generate a file name which is error underscore summary underscore the year, month, and the date plus CSV. So that would generate a file name, and then it also adds a path. So this is something that you definitely want to change, because probably you have a different path like home/pi or something like that. And then it prepares some other data, puts it into a big email object that I want to later use when I create the email template itself, and it gets the error summary, and then it checks if the error summary has any items. So obviously, if there are no errors, then it's not going to generate an email, and it's not going to create empty files either. And now it has read the email summary, it has generated the file name, you can see the file name here, and then it converts the email summary, which is an array, it converts to CSV, and it saves it to a file. So it saves it to the message.filename, which is defined here in this function node. And once that is done, then I have a similar function node. The only difference here is that here the file which is getting generated is an error underscore all, and again, year, month, and date. And then again, it also prefixes it with a folder name, which you want to change. And then it reads the error all. And it checks the length again, but I don't think it's necessary, because if one is empty, the other one should be empty as well. And by the way, if the summary is empty, the execution would never get to this point. But it still reads the all errors, it converts it to a CSV, and then it saves it to a file, where the file name is again configured in the message.filename. And then finally we have a template node, and this is the template node which actually generates the email that you can see here. So it's the email body. So you can see that it has a body, so error summary, and the today text. So that's the same date, which is that's actually generated here right in the beginning. So you can see that the today text is the current date, which we use to generate the file name from, and then we convert it to the local date string. So that's converted to a date text based on the local settings of your Node.RED instance, which in my case you can see it's here. It's UK format, so 24 of November 2023. And then we create a table, and in the table we create all these columns, and we start iterating the entries through the email. So the message.payload.email the message.email.summary content. So that's the array. So that's the array, that's the property that I populated right in the first function node, and it has all the summary information. So it's almost the same way how I created the template one for the UI, but now we are creating it for the email with a little bit more content. And I also add this text that please find the detailed error report in the attachment. So this just generates the email body in HTML format. And then finally I have this setup file where I do a couple of things. So first of all, I specify the topic, which is the error report, and that again it says error report hyphen and the current date again. So that becomes the subject of the email. The body we already generated with the template node before, and then we have to set up these attachment objects in order to pick up an attachment. So this attachment object, because it only has one single attachment, it's an object, and it has a path which points to the file name where the detailed errors are saved. So this file name, which again I store it here in the email.allerrors file name, and I also give it a file name, because then this is the file name that is going to appear in the email client. So you see it here. So this doesn't automatically pick up the file name of the file that was attached, but you can rename it. So I have to specify it here. So this is the all errors file name only. So that's just the same file name, but doesn't contain the /home/enigma. And that's it. So so sending this information into the standard Node.RED email node is going to take care of reading the email from the file, and obviously the body is coming in the message.payload, the email subject is coming in the message.topic, and then it just sends the email, and that's it. And if you only want to log it, you don't want to send the email, you can just delete this link, and that will only execute the first 6 nodes, which generates the file name, converts to CSV, and saves the file. So it will just keep creating a set of files, 2 files on a daily basis if error happened. And if there are no errors on that day, it's just not going to do anything. And what I have also done is I created these reset logs. So you can click here and that resets the logs. And you can see that both the summary and the details disappeared. And what you can also do here is that you can also trigger this reset from this change node. So let's say when the email is sent from this point, you connect to here, and then it generates the email, generates the files and everything, sends out the emails, and it resets the log. So if you do that, then you can, for example, configure this inject node that it triggers, let's say, specified. Oh, you don't have to do that. So let's say, I don't know, 3 o'clock in the morning. So, by the time you start your day, you would have the email summary. Or you can do it like midnight or whatever. And then it's going to trigger every single day, generate the email, and then clear up the log. So it starts with a start. Log from the point where the email from the previous day was sent. And that's it. And let's recap what we have seen in this video. So we learned about the error handling in Node-RED, how it happens when you just install Node-RED and start using it, and how you can use a special catch node in order to handle errors yourself, catch them instead of just then, them logging into the Node-RED log. And we have seen also a couple of different examples, how you can collect these errors, aggregate them, collect the errors individually, and then maybe have a simple emailing flow which emails the results for you every single day. I hope these examples were useful for you. As always, you are going to find the link to this example flow in the video description. But that will be all for today. Thanks for watching, and hopefully see you in the next video.